Hello! In today's training, I will show you how to configure and use auxiliary functions available with MTX control. Detailed description of those functions can be found in Functional Description Manual, Chapter 17. For our test, we use latest version of IndraWorks Engineering software and our MTX demo program. First, we need to configure our system parameters so we communicate online with our control. Then we go to NC configuration, then to basic parameters and auxiliary function tab. First, we open Class Definition tab, and we can see that there is up to 30 different auxiliary functions available with MTX control. We are using initial default set of parameters for typical machine, and some standard auxiliary functions are already pre-configured for us. So the first class is configured as active with bit type extension. We can activate built-in help function to find more information about available function types. So we can have bit, BCD32, integer, float, and double auxiliary functions. If we want to change auxiliary function type, we right-click on our class and then on Modify Info. Going back to our first class definition, we can see it has assigned name M for miscellaneous functions, and in channel dependency selection is configured to be channel dependent. We can also set functions to be channel independent, and the difference is that channel dependent function is configured and applied separately for every channel, and channel independent function is configured once for all channels. Next, there is a declaration of number of M codes available for every channel, and a default is 300 bit codes starting with number 0 and finishing with number 299. Next, we need to set acknowledgement requirements for every bit-coded auxiliary function. There is a flag field with bit mask for all those functions. Every byte represents 8 M codes, and for example, byte 3 bit 0 represent M24, and byte 4 bit 7 represent M39. And here a value 0 in the bit mask place means acknowledgement not required, and value 1 means acknowledgement required. So now, as an example, I'll change M code number 8 and make it as requiring acknowledge, and later we'll see the difference in behavior of those codes. All auxiliary functions work directly with the PLC interface, so they must have assigned for them unique PLC marker address. Our M codes are channel dependent, so for channel 1, default PLC address is 4700, and for channel 2, default address is 4738. Now, since we changed some parameters, we need to restart our system to activate them. Back in our PLC application, we'll create new program dedicated to our auxiliary functions, and we'll call it PR auxiliary functions. To make auxiliary functions easier to use, there is a library of data types dedicated to them. Those data types are located in library MT base, then data types, and then auxiliary function. For our 300M codes, there is dedicated data type MT underscore aux function bit 0300 underscore T. Back in our program, first we need to declare our M codes. Declaration can be presented in text or tabular view. So if you are not sure about the proper syntax of declaration, it is easier to use tabular view. First, we insert our new variable and name it mcodes channel 1. Next, we need to assign marker address. And we recall from our parameters, it was address 4700. So type here %MB 4700, and it means internal marker starting in byte address 4700. And for data type, we use special one from our library. We can switch view of our declaration to see it in text format. Now we create a basic logic for our M7 function. So first we insert reset coil for our M code. Then as soon as we start typing name of our M code variable, built-in AutoSense function will give us full name. Then we just hit dot. The list of M codes shows up and we select M007. Now we add M7 contact to our logic and then external switch connected to input 1. Next, we will make the same logic for M8 code simply by copying first rung and then replacing M07 extensions with M08 and input 01 with input 02. We need to add our program to PLC task. And then compile and download. Now we can test our program, and first we check switch number 1, then switch number 2, and for the rest of our tests we'll use IndraWorks operation software. Our operation screen is showing us channel 1 and our machine is in automatic mode. Now we will select program test M7, created to see how M7 auxiliary function works, and move our operation screen window so we can see simultaneously NC and PLC logic. This NC program has only 3 simple steps. In step 1, all axes will rapid travel to position X500, Y500, and Z500. In step 2, we activate M7 auxiliary function. And in step 3, we rapid travel all axes back to position 000. Before running this program, please recall that M7 auxiliary function does not require acknowledgement. So let's start this program and wait till it finishes. We can see axis moving forward, then M7 was activated, and axis moved back right away. This contact mcodes channel 1 dot M07 internally latches on, and we can reset it using our switch connected to input 1. Let's run again, but this time we slow down around M7 block to see better this transition. So here's normal run. Now we slow down. And here's our transition. We can see that bit in a PLC is set, and control right away starts next block and run all axes back. Now let's change our program and select new program test M8. Here we run the same motion, but our M7 call was replaced by M8. Before running this program, please recall that M8 auxiliary function does require acknowledgement. Now we start our program. See axis moving to position 500, and after reaching this position, setting auxiliary function M8. Please note that this time, when M code was activated, PLC contact M code channel 1 M08 was also set, but then NC program flow was stopped and system did not go to the next step. Also, a new diagnostic icon showed up, telling us that activated auxiliary function requires acknowledgement. To acknowledge this code, we reset it using switch connected to input 2. That will allow NC program to go to the next step, return all axes back to 0, and finish program. Please note that for both of those M code's active contacts, in order to be used again, they must be reset. So in case when program was interrupted or our switch fails, it is important to have additional way to reset them. For example, by using additional contacts activated by Reset button. To make our logic simpler, I'll not show those additional contacts later in this video. Now we go back to our project and add logic for M codes in channel 2. So first we create declaration of M codes for this channel by simply copying declaration for channel 1 and changing name to M codes channel 2. We can recall from parameters that address of auxiliary functions for channel 2 was 4738. So that is a number we put into our declaration. Next, we will create a logic for channel 2, and it will be a copy from channel 1 with codes M7 and M8 and switches at inputs 3 and 4. After compiling and download, we can check our new switches and start IndraWorks operation screen for more tests. First, we select program test M8 for channel 1. Then we switch control to channel 2. And here also select program test M8. So now we have two channels independently running programs with M codes requiring acknowledge. We can switch our display into two-channel mode and then start both of them together. We can see both channels stopped, waiting for acknowledgement. We can also see that M8 contacts in a PLC are also set for both channels. Now we'll reset signal M code channel 1.M08 using switch connected to input 2. Channel 1 right away went to next step, moved all axes back to 0, and finished program. Please note The channel 2 is still running and waiting for acknowledgement. Now we will reset signal mcode channel 2.08 using switch connected to input 4. And after this acknowledgement, channel 2 also went to next step and finished program. So we know how bit-coded, channel-dependent auxiliary function work, and now we can work on next available type of these functions. We go back to our parameters and see the second class of auxiliary functions already activated in our default setup. Those are channel-independent functions named S-codes. Those functions are typically used to transfer value of commanded spindle speed from NC program to PLC. That's why they are type float or real, and most of the times do not require acknowledgement. Before we start working on our PLC program for this class, we need to set marker address, similar like we did for M-codes. So those are channel-independent functions, and default address for float auxiliary functions is 6024. Going back to our PLC program editor, we'll add new program and name it PR Auxiliary Functions S. But first we'll check our libraries and see that there is a dedicated data type for this class of auxiliary functions called MTX func real_t. This data type is a structure of two elements. First element is Boolean bit for function acknowledgement, and second is a real value of transferred auxiliary function. Going back to our logic, first we declare our new variable. We name it S-code with PLC address %MB 6024 and type picked from the list. In our logic, first we create a rung for acknowledgement. And here we have active contact, reset coil, and acknowledgement switch. Next, we create a rung to transfer value of S-code from our dedicated structure into PLC variable. For that, we use function block type move. To make it always enabled, we simply delete en contact. Now we assign input, and it is SC code, then dot, and then pick up from the list. To add new variable on an output, we just type a name, my real value, and then let software auto-declare it. Next, we add this new program to PLC task, and then compile and download. We can see our program running, so now we open IndraWorks operation to make more tests. We switch our control into manual data input mode, and then simply type command S2000. Now we click Start button to execute this command, and right away we can see in the PLC our S-code bit active and my real value variable set to 2000. We can also see simplified value of this variable in the logic rung. With input 1 switch, we can reset our S-code active contact and then start a new S command, for example S350.8. And again, we can see new value immediately showing in the logic. We can also activate this auxiliary function using s equals command. For example, s equals 465.6. And we can see in the logic new updated value of our variable. I will reset scode active contact now, but it is not necessary for this type of auxiliary functions if acknowledgement is not required. Now we switch our control to second channel and issue new S command from this channel, for example S2455.7. Our variable in the PLC was updated to a new value, and we can see here how channel-independent auxiliary functions work. And they can be set from any channel to the same variable in a PLC. Now we go back to parameters and see third-class auxiliary functions created in default configuration. And those are channel-dependent functions named T-codes. And they are typically used to transfer number of active tools into PLC. So that's why they are type integer and do not require acknowledgement. Since they are channel dependent, they'll have different PLC addresses for every channel. So for channel 1, address is 6200, and for channel 2, address is 6216. Going back to our PLC, we'll create new program named PR Auxiliary Functions T. But first we check our library, and we can see that for integer auxiliary functions, there is a dedicated data type MT underscore auxfunc dint underscore T. And it is a structure with Boolean acknowledge and double integer value. Back in our program, first we declare our variable tcode channel 1 at address %MB6200 and dedicated type. Then we declare second variable tcode channel 2 at address %MB6216, and we are ready to create simple logic. PLC program for T-codes is very similar to program we created for S-codes. So for channel 1 we have a rank where we can see T-code active contact, and we can reset it using switch connected to input 1. Then we have similar rank for channel 2 with reset activated via input 2. And then we have two function blocks to transfer value of T-code from channel 1 into local variable T-code active channel 1, and from channel 2 into variable T-code active channel 2. After compiling and downloading, we can see our program running, and then use IndraWorks operation screens to make more tests. So we are showing channel 1 now, and first we switch control to MDI mode. Then we type in T441 command, and then push Start button. We can see right away that our T-code channel 1 contact is set, and value 441 is written to our variable T-code active channel 1. Now we reset our T-code and switch control to channel 2. Now in channel 2, we type command, for example, T4276, then activate Start button, and see T-code channel 2 contact active and new value in variable T-code active channel 2. That was the last step in today's training. Thank you for your attention.